All right, so solving quadratic equations using the square root property. Now again, this is a review from yesterday. So remember the square root property basically says this, that if you have some expression raised to the second power and it's equal to some number, just a number, then how can you get that expression by itself? Take the square root of both sides. So if you take the square root of both sides, but remember we saw yesterday that you need that plus or minus here. And so the square and the square root undo each other, so then u will equal plus or minus the square root of d. Okay? And it kind of makes sense because if you look at a simple example like x squared equal 40, I think we already did 49. Let's say x squared equal 121. What number times itself is 121? 11 and 11 what? Yeah, but what is it? Just 11? Negative 11 as well. Negative 11 times negative 11 is 121. So that's where you get that plus or minus. That's why you need a plus or minus there. All right, so when you take the square root of both sides, you're not just going to say x equal 11 because that's incorrect. You haven't found the solutions because it's not just 11. It's a positive 11 and what else? A negative 11. So plus or minus 11. All right, now, so in general, what you know is that whenever you have an expression squared equal a number, the best method to use is the square root property. That's the quickest method to use. All right, so number one, so you're going to solve all of these. Number one, let's suppose we have 4x squared plus 9 equal 0. 4x squared plus 9 equals 0. Now, you can, given this, and if you're not told how to solve this, then there are multiple ways you can do this. But first of all, you need to know what kind of equation this is. What kind of equation is 4x squared plus 9 equals 0? It's quadratic. And so there are several ways you can solve a quadratic equation. You can solve it by factoring, but are all quadratic equations factorable? No. In fact, this one's not. Now, that was 4x squared minus 9, then it would be. But that's 4x squared minus plus 9. Remember, that's the sum of two squares. Last semester, you learned that the sum of two squares cannot be factored. Remember that? So you wouldn't be able to factor this. The other method would be using the quadratic formula. But we haven't talked about quadratic formula yet. Now, you had it last semester, so you could do this using quadratic formula. But what they want you to do is to notice that this quadratic equation only has how many terms on the left? 2. What term is missing? The x term. So whenever the x term is missing, then it's easy just to use the square root property. So since the x term is missing, all you see is an x squared and a constant. You don't see that x term. So since the x term is missing, then all you do is get x squared by itself, and then take the square root of both sides. All right. So what's the first step? Subtract 9. So I get 4x squared equal negative 9. Is that correct?
Yes.
Okay. What's the next step? Put in the corner.
Square root property.
No. You got to get what by itself first? X squared. So you can do what next?
Divide 4.
Divide both sides by 4. And so the 4 divided by 4 is 1. So you get x squared equals a negative 9/4. Now what do? You use the square root property now. So what do you do to both sides? Take the square root of both sides. You don't square. You square root. Okay? So I'm going to rewrite this over. And now to get x by itself, you're going to take the square root of both sides, but remember, when you take the square root of both sides, you're going to need that plus or minus. And so the square and the square root undo each other, so you get x equal, now I'm taking the square root of a negative number, right? So I'm going to have what symbol? That I. So it's going to be plus or minus. Now I'm going to need that I there. What's the square root of 9? And what's the square root of 2? I'm the square root of 4. 2. So it's plus or minus 3 halves I. So that's your solution. Okay, number 2. Let's suppose you had some. All right, let's suppose you had this one. 2x plus 3 squared equals 12. 2x plus 3 squared equals 12. All right. Can I use the square root property? Yes.
Yes.
Because you have an expression being squared equal to a number. So the quickest way to do that is use the square root property. Don't follow this out, bring the 12 over, and then use the quadratic formula. You could, but you're spending too much time on this. So just use the square root property. So I'm going to take the square root of both sides. So remember using the square root property. So I'm going to just go ahead and rewrite this. And I'm going to take the square root of both sides. So square root, what else do I need? Plus or minus. Okay, so the square and the square root undo each other. So what expression is left on the left? 2x plus 3. Equal. All right, now remember, don't forget that negative was here. 9 and 4 would be what kind of numbers? Perfect squares. All right, so that's why when you took the square root, you got this nice 3 halves. But is 12 a perfect square? No, so you got to simplify the square root of 12. And so you got to think of perfect square. What's the largest perfect square that goes into 12? 4. So off to the side, you're going to figure out what the square root of 12 is, simplified. So that will be the square root of 4 times 3, correct? Now, which one of these is a perfect square? 4. So you're going to say, well, the square root of 4 is what? 2. So this is 2 square root of 3. Not 3 square root of 2, 2 square root of 3. So that's plus or minus 2 square root of 3. Then yesterday, if you recall, we talked about this, that if the square root is left in there, then would this be a rational or irrational number? Irrational. So since this is irrational, then it's okay if you just bring the 3 over and then divide by 2, because there's nothing to combine. So then if I subtract 3 from both sides, I'm going to get 2x equal,
3.
nope, negative 3 plus or minus 2 square root of 3. And then finally, divide both sides by what? 2. Okay, I just rewrote it over. I'm just going to divide by 2 now. Now notice, as I was walking around yesterday, some of you see that division symbol right here? Some of you only brought it up to here. It looked like this was the only thing divided by 2, but the whole thing's divided by 2, right? So you got to write things mathematically correct. That's one of the things you need to be able to do. Not just come up with the right answer, but make sure that mathematically everything you're writing is correct. Okay? All right, and so therefore x equal negative 3 plus or minus 2 square root of 3 all over what? 2. All right? Now you can leave your answer like that. No big deal. Now, here's where some of you make a mistake. Some of you see these 2's and you want to reduce these 2's. So I'm going to ask you this. I'm going to ask you, is this correct? Is this mathematically correct? All right. So I'm going to rewrite this over. Negative 3 plus or minus 2 square root of 3 all over 2. So I just rewrote it over. So the question is this, what I'm about to do, mathematically correct? 2 and 2 is 1, 2 and 2 is 1, and say that's equal to negative 3 plus or minus square root of 3 over 1. No, that is not true. Okay, you cannot do that because not only is 2 square root of 3 being divided by 2, but what else is being divided by 2? Negative 3. So if this is what you're doing, then what you're now saying is that negative 3, the only thing that was being divided by negative 3 was 1, and that's not true. What was negative 3 being divided by? 2. All right, so if you're going to reduce, you got to make sure like this. You got to make sure that all these terms here have something in common. Okay? All right. So some of you did that yesterday. So you got to be careful with this. Now, is this mathematically correct? Let's say we had negative 8 plus or minus 2 square root of 5 over, let's say, 16. Well, I didn't do anything yet before you can say yes.
You can do it because.
So all these numbers are divisible by what?
16.
No, 2. So 2 to 2 is 1, 2 to 16 is 8, 2 to 4 is 2 to 8 is 4. So this will be negative 4 plus or minus square root of 5 all over what? 8. So that is correct. Okay? So knows the difference between these two. All right. Now, number 3. Okay, let's suppose you had this. We had 3 times x minus 4 squared minus 15 equals 0. 3 times x minus 4 squared minus 15 equals 0. All right, now what kind of equation is this? It's quadratic, because if you were to FOIL it out, square that x minus 4, you would get an x squared. All right, so how do you want to solve this? I wouldn't do that yet.
Can we do the x minus 4, x minus 4?
No, leave it as x
Leave it
minus
like
4
that.
squared. Move the 15 over to the other side, and then divide by what? 3, and then do what to both sides? Square root. Okay, because you want to use the square root property here. You have an expression squared, right? But before you continue writing, you need to listen to what I'm going to say. What a few people would have done first is distribute that 3.
You can't do it because it's.
Very good. You learned something from last semester. You cannot do that. The only time you can use the distributive property, guys, the only time you can use the distributive property is if that expression that you're distributing is being raised to the first power. That's the only time. All right. So that you can use the distributive property. That you cannot, because x minus 4 squared is being what? Squared. The distributive property only applies if that expression is being raised to what power? The first. Okay? So don't distribute here. That's incorrect. All right. But you do want to use the square root property. So you're going to bring the 15 over. So you're going to add 15 to both sides. So I'm going to get 3 times x minus 4 squared equal what? 15. Then before you take the square root of both sides, remember, in order to take the square root of both sides, you have to have an expression squared equal a number. So you got to get that expression as being squared by itself. So 3 is not the one that's being squared. What's being squared? X minus 4. So that goes by itself. So that means I need to get rid of this 3. So what's the opposite of multiplication? Division. So divide, reduce, and so I get x minus 4 squared equals what? 5. And then finally, what's the next step?
Square root property.
Take the square root of both sides, square root property. Just like this. Now when you do that, what else must you insert? Plus or minus. So the square and the square root undo each other. So what expression is left on the left?
X minus 4.
X minus 4 equals plus or minus square root of 5. All right, so that's where I'm at. What kind of number is square root of 5? No. Rational or irrational? Irrational. Now, square root of 5 is not prime. 5 is prime, right? Because square root of 5 is not 5, guys. If you put square root of 5 in your calculator, you get 2 point something that keeps on going. Your prime numbers are any whole number whose divisors are 1 or itself, like 1, 3, 5, 7, 11.
We technically were wrong, but it's just what you're looking for.
What now?
When you said what kind of number is 5, technically we were
I didn't
wrong.
say what kind of number is 5. I said what kind of number is square root of 5.
Oh, okay.
Okay, that's what I asked. All right. So how do you get x by itself?
Add 4.
Add 4 to both sides. So I get x equal 4 plus or minus square root of 5. Now you can leave it like this, because this is what kind of number that I'm circling. Irrational. It has a square root in it. Now in my math lab, you have to separate them using commas. So in my math lab, you would say 4 plus the square root of 5, and what's the other solution?
1 minus square root of 5.
4 minus square root of 5. Okay? All right. And then just seeing if you remember how to write the answer. Suppose, I'm going to do one more with this. Suppose you had, all right, this is number 4. All right, suppose you had, let's say we had 2x minus 3 squared equal 144. All right, so just curious as to how you would write your final answer, comparing that with the previous one. All right, so do I have an expression squared by itself?
Yes.
Yeah, so right away I can do what to both sides? Take the square root of both sides. I can use the square root property. Let's go ahead and rewrite it over. All right, square root of both sides, square root of both sides. What must I insert? Plus or minus. So the square and the square root undo each other, so what expression is on the left?
2x minus 3 equals plus or minus square root of 144.
12, thank you. 144 is a perfect square. All right, so I no longer have the square root. I have 12, a positive 12, a negative 12. What kind of number is that? Rational or irrational? Rational. So since it's rational, remember that those 2 arrows I drew yesterday? You can do this now. You can write them as 2 separate rational solutions. So you're going to say 2x minus 3 equals what?
Plus
12, and then 2x minus 3 equals a negative 12. All right, so since it's rational, since the solutions are going to be rational, you write it like this. All right, now notice I went from this quadratic equation to 2 what? Linear. So how do you solve this linear equation?
add 3 both sides.
So 2x equal 15, so what's x?
Divide by
Divide by 2, so what's x?
x equals 15 over 2.
All right, so that's one of your solutions. All right, the other solution, how do you solve this one?
Add 3 both sides.
So 2x equals,
Negative 9.
then how to get x by itself?
Divide by 2.
So what is the other solution? Negative 9 halves? Okay, so notice the difference in which you wrote this. So the 144 was a perfect square, so I knew I was going to get rational solutions. So you're going to split it apart just like this. You're going to actually tell me what the rational solution is. When we did number 3, I'm going to cover this up. When we did number 3, square root of 5 is irrational. So So the easiest way to do it is just to bring the 4 over and you're done. Now, you could have, just to let you know, you could have done this with this, just like we just did, x minus 4 equals plus or minus square root of 5. So you could have done the same thing. Just watch. You could have said x minus 4 equals what? Square root of 5. And then x minus 4 equals what? Negative square root of 5. Oops, sorry. Negative square root of 5. And then how do you get x by itself? Add 4 to both sides. Now be careful though. When I did this one here, when I did this, these are like terms, right? I can add 12 and 3. Are these like terms? No. So the only thing you can do is write it as 4 what?
4 square root of 5.
No. 4 plus the square root of 5. Okay? All right, and then this one would be what? 4 minus square root of 5, which is what we had here. See it? All right. Okay. All right, so that's going to take care of the square root property with this.